App state is vital in FlutterFlow for managing app data, but by making it persistent, you can mimic an internal database. This ensures your app state is saved even if users close the app, enhancing reliability. Simply click on Apps Values in the left-hand menu, select App State, click Add App State Variable. Type a name of the variable, select the appropriate data type, and click Create. Now toggle the Persist option to turn it on and click Save. Now your app will retain the state of this variable even if the user closes the app, enhancing data reliability and user experience. Storing complex data in FlutterFlow is simple with custom data types. By defining structured data types, you can manage intricate data within your app more effectively. Click on Data Types in the left-hand menu, make sure the Data Types tab is selected, click on Create New Data Type, type a name for your data type and add fields for your data structure, click Create and Save. Now your app can manage complex data structures, making it easier to handle intricate information. Save time by importing JSON data directly into FlutterFlow to create custom data types. This streamlines the process of setting up your app's data structures. Click on Data Types in the left-hand menu, make sure the Data Types tab is selected, click Create Data Type from JSON, upload your JSON file, review the generated data types, and click Save. Now your app will automatically have custom data types set up for your JSON file, streamlining your data management process. Parsing JSON data is a breeze in FlutterFlow. Use custom data types to automatically structure JSON responses, making it easier to handle API data within your app. Click on Data Types in the left-hand menu. Make sure the Data Types tab is selected. Create custom data types to match the structure of your JSON data. Set up an API call and map the JSON response to your custom data types. Click Save and use the data in your app. Now your app will automatically structure and manage JSON responses, simplifying data handling. When making API calls, opt to return JSON instead of a regular string. This makes it easier to work with structured data and integrate it seamlessly into your app. Additionally, without JSON, you won't be able to parse the response properly, making it difficult to work with the data in your app. Click on API calls in the left-hand menu. Set up or edit an API call. Ensure the response format is set to JSON and the response itself is set to JSON as well. You won't be able to parse the response properly unless it's in JSON format. Optionally, map the JSON fields to variables or data types in your app, then click Save. Use app state to make your API results reactive. This keeps your app's interface fresh by automatically updating whenever new data is received, creating a dynamic user experience. Click on the app values in the left-hand menu. Select app state. Click Add App State Variable. Type a name for your variable, select the appropriate data type, and click Create. Click on API calls in the left-hand menu. Create a new API call or edit an existing one. In the workflow of the API call, add an action to set app state. Select the app state variable you created and map the API response data to this variable. Click Save. Go to your UI builder and bind the relevant UI elements to the app state variable instead of directly to the API call. Save your changes. Now your app will display data reactively, automatically updating the UI whenever the API call returns new data, ensuring your app remains dynamic and responsive. Creating real-time apps in FlutterFlow is possible by enabling the streaming API feature. This lets your app receive live updates, perfect for building responsive, dynamic applications. Click on API calls in the left-hand menu. Click to create a new API call or edit an existing one. Toggle on the Enable Streaming option to allow the API call to receive live updates. Map the streaming data fields to variables or data types in your app, then click Save. Now your app will receive real-time data updates from the API, allowing you to create dynamic, responsive applications that reflect live information. Use function argument callbacks in your custom actions or widgets to send data back to your app. This approach allows for greater flexibility and interaction within your custom features. Click on Custom Code in the left-hand menu. Select either custom widgets or custom actions depending on what you're creating. Click Create New Widget or Create New Action or edit an existing one. Click Add Argument to define the function's input parameters. Scroll to the Actions section within the widget or action editor. Define the callback function to handle the data or action that will be sent back to your app. Use this callback within your custom logic to pass data back to the main app when the custom action or widget is executed. Click Save. Now your custom widget or action can send data back to the app using the callback mechanism, enabling more interactive and flexible custom functionality within your app. When working with variables in FlutterFlow, it's a good practice to set a default value that clearly indicates when the variable is uninitialized or null. Using a known value like e as a placeholder helps you quickly identify when variables haven't been properly set, allowing for easier debugging and more reliable app behavior. In the UI Builder view, select the widget or component where you want to bind the variable. Click on the widget and select the variable you want to bind. Enter a default value for the variable in the default variable value field. Use a known placeholder like e to represent an uninitialized state. Set the UI Builder display value to the same known value if necessary for easier visual debugging during development. Click Confirm and save your changes. Now your variables will default to a known value like e, making it easy to spot any issues with uninitialized variables during app development and testing. This practice enhances your ability to debug and ensures that your app behaves as expected. When designing your app's interface, use the Show Overflows option in FlutterFlow to quickly identify and resolve layout issues. This simple tool can help you fine-tune your UI for a polished final product. In the UI Builder view, select the screen or widget where you want to check for overflow issues. Click on the Overflow toggle icon in the top. Enable the Show Overflows option to see where the content might be exceeding its bounds. Adjust your layout or elements to fix any overflow issues. Now you'll be able to easily identify and resolve layout issues where content overflows its container, ensuring a polished and user-friendly interface. Instead of creating custom functions for single-line logic, use code expressions. This keeps your code base cleaner and your app more efficient. In the UI Builder view, select the widget or component where you want to add logic. In the Properties tab for that widget, bind that widget value to a variable and choose a code expression. Make sure the argument is set to the variable you're trying to alter. Add the desired code expression in the expression field. Click Check Errors to ensure there are no issues with your code expression. If everything is correct, click Confirm and then Save. Now your app will execute simple logic efficiently using code expressions. When working with data tables in FlutterFlow, use a container to fetch and manage the data. This approach helps organize your data handling and keeps your UI components responsive. In the UI Builder view, select the screen where you want to add a data table. Drag and drop a container widget onto the screen. Select the container and click Add Query in the right-hand panel to set up the data source or API call within the container. Configure the query to fetch the data you need. Drag and drop a data table widget inside the container. Bind the data table to the fetched data by selecting Generate Dynamic Children from Variable in the data table's settings. Now your data table will dynamically fetch and display external data. ensuring a responsive and organized UI. To create a responsive layout when using columns, divide your screen width by the number of columns you need. This ensures your app looks great on any device, adapting seamlessly to different screen sizes. In the UI Builder view, select the screen where you want to create responsive columns. Add a row widget to your layout, ensuring the columns are going to be set up next to each other. Calculate the screen width by dividing by the number of columns you need. Set the width of each column using the calculated value to ensure responsiveness. Now your app will display a responsive layout with columns that adjust automatically based on screen size. Stacks are great for displaying alternative views within the same screen. If you need to switch between different UI elements, consider using a stack for a smooth and flexible design. In the UI Builder view, select the screen where you want to display alternative views. Add a stack widget to your layout. Add multiple child widgets inside the stack. Use conditional visibility to toggle between different views within the stack. Now your app will be able to switch between alternative views seamlessly, creating a more dynamic user experience. Within rows and columns, use flex and expansion widgets to create more dynamic layouts. This simplifies your design and allows your UI to adapt more naturally to different screen sizes. In the UI Builder view, select the screen where you want to use Flex for layout management. Add a row or column widget to your layout. Click on the child widgets within the row or column. Set the Flex property for each child widget to determine how much space it should take relative to others. Now your app's layout will be more flexible, adjusting automatically based on content and available space. For advanced UI designs, consider using a floating bar within a stack. This allows you to create layered interfaces where elements can float above the main content, adding depth and interactivity. In the UI Builder view, select the screen where you want to add a floating bar. Add a stack widget to your layout. Add the main content widgets to the stack. Add a floating bar, such as a container or a button, as the topmost widget in the stack. Adjust the position and styling of the floating bar to achieve the desired floating effect. Now your app will have a floating bar that remains above other content, adding depth and interactivity to your UI. When working with lists, leverage the index to determine each item's position. This is particularly useful for tasks like numbering list items or creating unique identifiers. In the UI Builder view, select the list view containing the items you want to display. Click on the widget inside the list view where you want to display the item's position, for instance, a text widget. In the right-hand panel, connect a variable to this particular text widget. Choose Index in List option from the Available Options dropdown. Confirm the settings and save your changes. Now your list items will automatically display their position within the list, which is useful for numbering, ordering, or providing unique identifiers for each item. Use the map function to efficiently access specific fields within your data list. This helps streamline your data processing and makes your app more understandable. In the UI Builder view, select the list view where you want to map specific fields. Click on the widget inside the list where you want to display specific field data. In the right-hand panel, connect the specific variable to the widget where you want to display. Choose the Map List Items option from the Available Options dropdown. Select the specific field you want to access from the data structure, for instance, name. Confirm the settings and save. Now your app will use the Map function to access and display specific fields from the items in your data list. When you need to narrow down your data, use the filter function to isolate the exact information you're looking for. Combine it with sort or unique for even more precise results. In the UI Builder view, select the list view or data list where you want to filter your data. Click on the widget or list view where the filtered data will be displayed. In the right-hand panel, Connect the specific variable to the widget where you want the data to be displayed. Choose the Filter List Items option from the Available Options dropdown. Set the filter condition by selecting the field you want to filter and defining the condition. For instance, field name needs to be equal to James. Confirm the settings and click Save. Now your app will filter the data in the list to display only the specific results that match the condition you set. Need to flip a condition quickly? Use the inverse flag in conditions to simplify your logic and keep your code clean and efficient. In the UI Builder view, select the widget where you have a condition set. Toggle the inverse option to quickly inverse the condition. Confirm the settings and save. Now your condition will be inversed, simplifying your logic and ensuring the correct behavior based on the opposite of the original condition. Avoid unnecessary iterations by using conditionals to limit loops. This not only optimizes your app's performance, but also keeps your logic more manageable. In the UI Builder view, select the list view where you want to apply a limit. Click on the widget inside the loop where you want to set the condition. Choose Conditional Visibility and then define the condition that will limit the loop's execution. For instance, display the first 5 elements only. Confirm the settings and save. Now your loop will only display the specific widgets that match the conditions that you have specified. When working with loop constructs, employ page state variables to track and manage data efficiently. This ensures smoother data handling and better app performance. In the UI Builder view, select the screen where you have a loop structure, such as a list view. Click on the page parameters in the right-hand panel, then go to Local Page State Variables. Select the topmost element in your screen, then go to the right-hand pane and select Local Page State Variables. Create a page state variable, for instance, a loop index, to track data or states within your loop. Use this page state variable in your loop logic to control when your loop is iterating. Now your loop constructs will be more efficient with data tracked and managed using page state variables. Always test your custom functions before integrating them into your app. This simple step can save you from potential headaches and ensure your app runs smoothly. In the custom code view, select the custom function you've created. Click Test Function in the function editor. Input the necessary test parameters or arguments for the function. Run the test to see if the function behaves as expected. Check the results and make any necessary adjustments before integrating the function into your app. Now you'll ensure that your custom functions work correctly before deploying them, reducing the risk of bugs or issues in your app. To streamline your app's functionality and avoid duplicating your work, you can create action blocks in FlutterFlow. Action blocks allow you to define reusable actions that can be easily applied across different parts of your app. This not only saves time, but also ensures consistency in your app's behavior. In the UI Builder view, select the widget where you want to create an action block. Click on the Actions tab in the right-hand panel. Click the Create Action Block button to start a new action block. Enter a name for your action block in the pop-up that appears, then click Create. In the Action Block editor, click Add Action to define the actions you want to include in this block. Configure your action settings as needed and add more actions if necessary. Save the action block. Now your action block is created and can be reused anywhere in your app. This helps to maintain consistency and saves time when building complex workflows. When hunting down bugs, make the debug console your best friend. It provides real-time insights into your app state behavior, helping you quickly identify and resolve issues. When you are previewing your app in the test environment, make sure the debug console on the left-hand side is open. Monitor the debug console for any errors or warnings as you interact with your app. Fix the issues in your app based on the information provided in the debug console. Now you'll be able to troubleshoot and fix bugs more effectively, ensuring a smoother and more reliable app experience. By joining our rapidly growing Patreon community, you'll not only get access to all the apps I've built on this channel, but you'll also unlock a wealth of exclusive content. This includes our Q&A sessions, behind-the-scenes series, and a masterclass where I deep dive into a variety of topics. Plus, you'll get access to our weekly series where I discuss the apps I'm currently building and planning to build. If you're enjoying the content here, you're going to love the perks we offer on Patreon. If this sounds like something you'd enjoy, click the first link in the description to become a member.